Well, all right, we are at a special location in Canada. As you guys have seen on the channel, we are looking at doing an ICF addition on the backside of the castle to, at minimum, add a master bath. And there are some other key features within the ICF world / rebar world that intrigued me. We've got a slight connection in that area, so we are here at MST BAR composite rebar. And you may ask, well, it's just rebar. It's not just rebar. This is not metal rebar. Let's go inside and talk about it. So we've been told to head down this hallway and look for Borna. Let's go see if we can find him. I see some rebar and a gentleman. Are you Borna?
Yes, sir.
Hello, Borna.
Nice
Matt Parr. Nice to meet you, sir. I hear that you are the expert on MST BAR, and you've got some examples before we head out into the plant and truly see how this stuff is made.
That's right. Thank you very much, Matt, for coming to our plant. We're a manufacturer of MST BAR. MST BAR is a glass fiber reinforced polymer bar.
And that's a big stick right there.
Number 11 bar, Matt. That's right. And you can see that I'm holding this bar, and this bar is exactly sounds like metal, but there is no metal in there. These are made out of glass fiber reinforced polymer bar. MST BAR has a very unique characteristic: high tensile strength, over 145 KSI, high modulus, high bond strength, high shear performance. So these bars are meant to replace steel, period. And there's no corrosion out in the market. The weight of the material is amazing because...
Well, I was going to say, I see that you've got a very similar, obviously this one has zip ties, and the metal rebar has metal wire ties.
That's right.
So I'm going to roll this chair out of the way here. We're going to turn this camera one hand.
That's a number 8 bar.
Three fingers.
Yep, that's right.
Right, and this is to get a good comparison, this is the same layout.
Exactly.
With the center bar being a little bit off of center. Fiberglass versus metal. Now let's see.
What's your back, Matt?
Oh my. I'm pretty sure you can tell by how red the face I am. Holy cow. And what you're saying is, Borna, is this is a direct one-to-one derivative.
That's very true, Matt. That's very true. And the weight is a quarter. And you take the corrosion out of your equipment, out of your concrete once for all. There is no metal. There is no corrosion inhibitors. There is no additives. You don't need any of those when you use fiberglass rebar.
Okay. And you said a quarter. So the weight of this one is 4 times the amount of this one if you do that in the other way, right?
Density of steel is 7,850 kilogram per cubic meter. Density of MST BAR is 2,100 kilogram per cubic meter. So that's about 4 times lighter.
I'm gonna let you all do all that conversion math and figuring out in your head. But basically it's 4 times heavier the metal is, or the fiberglass is 4 times lighter.
That's right. Also, Matt, I gotta tell you, we can bend this bar to any shapes and any geometry. All we need is your shop drawing, is your bar list, your bend bar list, and we produce any bend shapes. Let me show you some of the bend bars we do. We produce any bend shapes to any geometry. These are fairly and the tolerances of all of our bend bars are plus minus 1/4 of an inch. That's the beauty of our process. We produce bars as small as this. That's my hand.
Did you make a slinky?
That's right. That's exactly what we make. And you can adjust, we can make the spiral shaped like that. When you get to the job site, you can adjust it and attach all your bar into it. And imagine, Matt, you're doing a big caisson job and you got that heavy metal spiral around. Well, look at that, Matt.
Well, I was going to say, I've seen another example of that over here. We'll show them here in just a second.
I can grab this whole big slingy, and these are so strong and lightweight that I can grab them, adjust my spacing to anything the engineer specified, and use it. And here you go, Matt. You can show them. I was going to
say, your conference room table intrigued me as soon as I walked in, but I wanted to wait and mention it. I mean, you guys can see that they took this type of spiral, and they used vertical bar, and then they zip tied it to hold the gaps properly if this was an engineered structural column, and it's got concrete on top and bottom with a glass top. So you're using the MST bar as the column support for the table. Yeah. And all it is MST bar. I mean, the concrete is just holding everything together top and bottom, but it's truly supported by the rebar. So I don't know. By no means am I saying that glass is heavy.
Yeah, we got more examples.
That's pretty cool. And that's just...
Yeah, and not only that, but Matt, you can imagine this is a number 8 bar, you know, bent in a hook. These are very complicated bends for precast applications.
And this is in case you work sheep.
That's very true. That's very true. And so on. So we produce any bend shape. Also, Matt, we have another very cool product that I have to introduce you to.
Okay.
This product, fiberglass rebar MST bar, does not conduct cold or heat. So we talk about these 2 cages. Here's the problem. You got a summer day, it's very hot outside, and you got these bars sitting in front of the sunlight for a day. Next day you go in and you touch
burn your
these
hand.
bars, you burn your hand. You touch fiberglass rebar, you don't feel anything because this material does not conduct cold or heat. Where do we use this advantage? We use it on a new product that we developed called thermal break. So Matt, let me tell you what thermal break is. Thermal break is a material that a combination of concrete, MST bar, and foam. And this material is going to sit right between your balcony and your slab, with the window sitting right on top. So you can see the arrows showing that the balcony is in this way. So what this product does, it breaks the continuity of the cold and heat into your slab. So it breaks that continuity of the thermal effect, and it saves tons of energy. It brings comfort to homes. So this product is becoming mandatory in New York, in Toronto, in Vancouver, in many states right now. And because it saves energy, it's a lot greener product. So it's a very cool product.
So you state that the fiberglass rebar, regardless of its state, bent, straight, woven together, does not conduct heat or cool. Exactly. Right? So it's never going to be cold, it's never going to be hot.
Exactly.
Let's talk about electricity.
Yeah, that's a good one, Matt. That's a very good one.
So if it's not conductive, meaning absorbing heat or cold,
yeah, that's right, Matt.
That doesn't necessarily mean that it won't be conductive with electricity.
Exactly.
However, if I understand a previous conversation, if this is going into an application, let's just use an in-ground pool, for example. You don't have to ground the fiberglass rebar because it's also not conductive when it comes to electricity. Whereas if you use this metal rebar, any metal rebar, doesn't have to be this grid assembled, wired together, it can just be a straight piece of rebar. If it's near a water style application or the ground is saturated with water and holds water frequently, you have to ground your rebar grid to ensure that it does not conduct electricity from a lightning strike and or an exposed wire in a home's wall or anything like that.
Exactly, Matt. Exactly.
Whereas the fiberglass rebar, you don't have to do that at all.
That's very true. You don't need grounding. We do this in a lot of heavy infrastructure projects such as LRT tracks, train tracks, that they need to isolate the foundations, otherwise the steel rebar will heat up and cause failure. Or swimming pools that you mentioned, Matt, that you don't need to use any grounding materials, less brass, less electrician to the job site.
Less concern.
Less concern, absolutely.
With the same amount of rigidity.
Absolutely.
Well, you ready to head out to the plant?
Yes, sir. Let's walk in.
Well, let's do it.
Thank you.
Well, all right, so here we are on the incoming side of things. This is the raw material, and I'm here to tell you there is a lot of it. And my understanding is this comes in rolls, and that roll consists of a lot of layers and wraps of this specific thing right here.
Yeah, that's right, Matt. Matt, glass comes in a form of a roving. These rovings are ECR glass, a boron-free glass. These glasses do not rust. There are generations of glass 40 years ago, the glasses that had a corrosion problem. Today glass, these are boron-free. And if I open one, I was going to say,
when he says glass, these are hairs, if you will, fibers that consist of multiple individual strands of fiberglass.
That's very true.
That are, how long is a roll, for example? Is that a 2,000 foot roll, or?
That's about 10,000 linear
10,000 lineal feet of this product on one roll, and there's probably 100 rolls on that skid.
Yes.
So,
and this is very strong. When you combine this in the mold and tooling with the high performance epoxy and vinyl ester, and you bind them together, that's where you get that beautiful fiberglass rebar that can take a lot of force before they fail.
so this product starts as silica.
Exactly, it's sand.
They turn the sand into a glass marble.
That's very true.
They put that glass marble into some type of heater that gets really hot. It takes a really high temperature. I don't know the exact temperature, you guys can Google that, but it takes a really high temperature to turn that glass marble into a molten lava, and then it gets extruded into these individual hairs that you can see there, and then they actually blow cool air onto it and turn it into a rope, or also fiberglass insulation, or also fiberglass fibers that are then chopped up and used for fiberglass hulls in boats. But it starts its life off as sand, which is just mind-boggling, and most people don't know that.
And Matt, that's exactly the point that a lot of people ask about why this material is greener than steel. Well, because 85% of that rebar that I was holding in my hand is made by silica. This is an inert material.
Correct. So I'm going to state that again. 85% of that bar, that glass bar called rebar, is 85% sand.
Exactly.
To simplify it, silica, sand, same thing.
The other question that the audience might ask is, hey, how does fiberglass rebar behave in fire application? It's a polymer base. Hey, don't forget that 85% of that is glass, and glass has a much higher melting temperature than steel.
Correct.
So even if your polymers start to degrade in your structure because of fire, the glass is holding like a post-tension cable in your slab. So we did fire testing, and fiberglass holds over 3 hours fire rating.
3-hour fire rating, and I'll try to remember to Google it and put it in a text right here in this portion of the video. I'm going to put a disclaimer out there and say I'm not confident in this answer, but my memory serves me the last time I visited a fiberglass manufacturing plant, the temperature was somewhere around 3,000 degrees to melt that glass. So if you think about that, a common house fire that does not have other fuels to really make it hot, and you're just burning wood and you're adding oxygen from wind, 3,000 degrees
you won't get
not something you're going to get to very frequently. A grease fire might, because there's a fuel to it, but other than that, it's going to be very difficult to get to that temperature that actually melt this, which is why you get the 3-hour rating. I mean, let's talk about gun safes, right?
Yeah.
3-hour ratings is it's a high quality safe.
That's
very, very high dollar.
You only need 2 hours. Because you only need 2 hours fire rating.
This is true. Well, all right, you ready to go look at some manufacturing?
Let's do it.
All right.
Let's do it.
Well, okay, Borna, I come out here to look at your inventory and talk about the availability, and I'm like, wait a minute. I see multiple colors. You can tell there's a light tannish blue and then a very obvious blue. Help me understand this a little bit.
Well, welcome to a little inventory of materials we have. As you can see,
a little. Come on, Borna. There's a lot. I mean, it just keeps going.
Yeah, we can probably build
and keeps going and keeps going and keeps going. So availability is not a concern, right?
Very true. That's one of the misconceptions out there, that fiberglass rebar is difficult to find, not available. That's not true. MST BAR is a commodity.
Maybe it's just because nobody knows about it, Borna.
That's very true.
Which is kind of why when I heard about it, I said, I want to know about it. So we're going to make sure that my people know about it, all right?
Well, thank you very much.
So ample inventory, and I also see, Borna, that that looks like a 20-foot stick, and that looks like a 10-foot stick. So are these already ordered, or?
Yes, let me get back to you on the question of the difference in color.
Okay, let's do that.
What you see is blue color and a green color. Everything you see in a blue color, we call them a flat rock rebar. These bars doesn't need to necessarily have the alkaline resistance for 1,000 years or performance difference of a bridge deck. These bars can be used next to your driveway, your swimming pool, your curbs, your inside your big warehouse. Wherever you use wire mesh, you place our blue bar, a 3 max and 4 max bar, or a number 3 grade 1 and number 3 grade 2 bar. You place them every 12 to 16 to 18 inches center to center. These are the greatest solution out there for temperature shrinkage cracks. If you get the shrinkage of the concrete, the bars prevent all the temperature shrinkage cracks. They are lightweight, they're easy to install, easy to tie, and they are extremely cheap. That means not cheap. Cheap doesn't mean they're bad quality.
Right.
Cheap means that they're just very inexpensive to prevent the temperature shrinkage crack.
Cost effective.
Cost effective.
To
I like that.
provide a solution in the shrinkage arena.
Thank you very
right?
much, Matt, for helping me out on that. The next one you will see is a green bar. The green bar, as you can see, they all tagged with the barcode, with 40Q structural, ESR number. These are ICC approved, ASTM tags, barcodes, and lot numbers, website, everything. These are a structural bar. These are the bars you put it on your walls, foundation walls, the slabs. They come in different thicknesses, all the way from number 3 to number 11. We produce number 14 to number 18 on custom basis. But you know what's the beauty of this, Matt? Is we can custom length these bars without extra charge. Our production process is like an unlimited noodle making machines, where the bars can cut to any lengths we want by going to the computer and punching the numbers without having any waste. So instead of buying a 20-foot length and cutting it down, or let's say you want a 30-foot length, what are you going to do? You want to get a 40 and cut down the 10?
Absolutely not.
You don't want to do that. Well, you just give us a call and we make you 30 foot at the price per linear foot of a standard length.
So if I share my print with you,
Yep.
and I have wall heights that are 9 foot or 10 foot or 11 foot, or if I have a 10 foot and then a 9 foot, and let's say I'm 20 by 20, I'm speaking to these details because my audience has seen the print for my addition that I'm going to be doing. You'll send me bar that is proper for my vertical elevation length and my horizontal wall length. You'll look at that print and you'll say, here's the package
That's very true.
that you would need.
That's
right?
very true.
And we'll get into some more details when we get into the quality side of things about what else MST BAR offers to a customer. So I'm a potential customer. We've used metal rebar 100% of the time, right?
Yeah.
So when I do my bids for ICF, I use 1 ton per level of rebar, which in metal typically equates to 155 sticks.
Yep.
Okay.
Yep.
I'm setting the stage for a conversation that'll come a little bit later in this video because of how MST BAR handles their customers for the technical side and the actual application needs.
That's very true.
Okay. So we've got custom lengths. They'll cut it to whatever you want. And if I understand what you stated, you're producing a stiff noodle.
Yeah.
All right. Similar to a spaghetti noodle that hasn't been cooked yet. All right. Am I to assume that the longest length I can get in a straight bar is 53 feet because that's the longest semi-trailer?
Exactly. In fact, Canadian market, sometimes they allow 60-foot bars to overhang. So absolutely 60 foot is the longest length you can get because of the trailer.
So check with your local DOT to find out what the longest length that can come from Canada, MST being the port of origin, if you will, to your location. You may be able to get 60-foot bar.
That's very
But 53 feet would be a good number to go off of because that's a guarantee.
Absolutely, yes, man.
Excellent.
Let's walk around and I show you guys the plan and how we produce this.
Excellent. So I want to put a disclaimer in here. You guys are going to think we're hollering at you because inside the plant it's very loud, so we're going to have to talk very loud. We've tried independent mics and it didn't matter. The camera audio is just as good as the mic, so we're just going to talk really loud. And as you can see, we've got some bar coming off the line here going into a chute. If you want to come a little closer, we're going to get friendly here so that everybody can hear you.
So Matt, as you can see, the bars are being pultruded as a rebar, a finished product. Each bar is tagged and barcoded as the bars are going out. This is a fully finished product. They're still a little bit warm because they're still going through the process.
The curing?
The curing process. So they're still a little bit hot. But at this stage, they're easy to handle, to move around, get ready for packaging and testing. The key here, Matt, is for these fibers to be perfectly packed and fit into a very tight mold to make these fibers that I showed you extremely straight, packed properly together to make this part. While we are doing this, we have to ensure that this rib on the bar, because these ribs are everything to adhere to the concrete. That's the key element for our bar. You can have the strongest rebar in the world, the strongest concrete, but if these two doesn't bond together, it does not work. And these ribs on the surface of the bar are everything. A lot of people ask this question, hey, Borna, fiberglass rebars are brittle. Well, I'm gonna drop this down, Matt, and let's see if they're gonna break. And these bars can go under a very nice deflection without failure, Matt. They are very, very strong. As the bars get cut, you can see, Matt, that the machine automatically spits the rebars out, and as they come out, after a few seconds, these tables open up, the bar drop down, and all the bars get packaged into a big master bundle. Our number 3 at 500, our number 4 at 250, our number 5 has 200, but the volume of the package never changed because the size changed.
Right. So what he means there is the diameter, the outside diameter of the number 1, number 2, number 3 changes.
Absolutely.
So the actual full diameter of a bundle stays the same, but the quantity of sticks is different.
Exactly.
And back to the concrete has to bond to it. If it was a slick surface like this, the concrete does not bond well.
Exactly.
You'll see a small crack from the concrete to that metal where it's separated because of the shrink in the concrete.
That's very true, Matt, but it's not only that one. The other problem is when you go on a cyclic loading, when you have a slab that's going over millions of cycles, these bars, if they don't adhere properly, they start to move. As soon as that rebar starts to move in a concrete, you're gonna get a shear crack. Your punching shear and your shear capacity goes down. So the bond strength is the key for the proper rebar, and it's almost the most important thing you can have.
So, you guys will notice we're at the end of the line.
Very true.
There are specific processes behind the camera right now that we can't share.
That's right, Matt.
So we're speaking to the details of the fabrication process without giving the proprietary information.
Not all fiberglass rebars, Matt, are manufactured equal.
I understand.
There are differences between the products, and everybody has their own system and their own proper treatment.
So just because you hear the term fiberglass rebar, that does not necessarily mean you're buying the highest quality, because it really comes down to how it's made.
Absolutely, absolutely.
Where are we off to next?
We're gonna start testing some bar and break them for you.
Excellent. All right, we did this backwards, but this is the entering side of the proprietary information. What is directly behind the camera I cannot show you. But this is how the spools are unwound and they go into the machine literally right there, and I cannot show you that way, but this shows you those spools that you saw at the incoming inventory and how they're unwinding and being threaded at a specific rate, at a specific combination, going into a solution, and then all the magic happens right behind the solution, right, Borna?
You got it, man.
I'm not turning the camera any farther, sir. No farther.
Thanks, man.
All right, so this is the staging area. It kind of preps the product to get it ready to go out the door and go on a flatbed trailer. But I wanted to stop in here because I think this is interesting. Whenever a person's on a job site, thank you, man, behind the scenes. You're literally behind the scenes now. Whenever you're at an ICF job site or using rebar in general, Aaron knows this better than anybody else. You grab one stick of 1/2 inch number 4 rebar, right? This is a bundle of 25. That is literally, it's a little hard to get above your head, but that is one hand. And that is 25 sticks. 1/2 inch bar. So just imagine your laborers, you're giving them an easier job and you're still dealing with a very strong product. I just can't get over that. That's just amazing.
That is the work smarter, not harder way.
Work smarter, not harder.
Yes.
You got it. Man behind the scenes said it best. So now I hear, Borna, we're gonna go break some stuff.
Yes, sir.
Let's go break some stuff. All right, Borna, so we are in the testing / breaking area, and you have loaded the machine with which bar, sir?
That's number 5, 15 millimeter diameter. Cross-sectional area on that bar is 200 square millimeter. This machine, as you can see, it's 1,000 kilonewton, 100 tons capacity machine.
Thank you for that conversion.
That's
My
very
people will
problem.
appreciate that.
Absolutely, Matt. And we are going to test this. And we're going to start the test right now, Matt. And I'm going to show you some of the cool stuff. So as you can see here, Matt, I'm going to go ahead and start the test. This material, I'm going to clear all my loading, and I'm going to start this test right now. What you can see here, Matt, you see a stress strain curve. This is a tensile stress applying on the bar, and this is the elongation on the bar that is happening in percentage. That's a very small percentage. At the beginning of the test,
This is 1%.
that's right. That's
Okay.
exactly right, Matt.
Just so
it is very, very small. I can go back and forth between PSI and MPa for the people who recognize imperial and the people who knows metric system. So right now there's 7,500 PSI force on this. As you can see at the beginning, the material is, the hydraulic is adjusting.
Yep.
Once this material is reached to about 100, you see a beautiful straight line shooting up. Steel rebar grade 40 or grade 60 means 40,000 PSI or 60,000 PSI. That's 40 KSI or 60 KSI. What does it mean is when this number right here reach to 40,000, that's where the steel is start to yield.
It's
Or-
going to stretch
Exactly.
at that point.
And when it gets to 60,000, the steel start to completely go
Degrade
away.
completely.
Exactly. So right now we reach 42,000.
I was gonna say, we're going there fast, people.
We are already passing that line. And what you also see, I'm going to convert this to MPa so people can see. That's a grade 400 megapascal. So grade 400 MPa bar is already pretty much gone right now.
And now you're starting to see
you
that
see a
straight.
beautiful straight line. I'm gonna go back to PSI again. Matt,
Oh my gosh,
we
we're almost at
already
80.
Past 60,000, exactly.
And seriously, people, the bar's not broke.
Exactly.
I'm not going to open the doors now, but the bar is still intact.
Exactly. That's what I'm actually going to do right now, Matt. That I'm going to slow down the machine, right? And I'm actually going to remove that extensive meter that I put there because we
don't wanna break your meter.
We don't want to break this. This is about a $10,000 worth of equipment that we really don't need to measure the ultimate strain because all we care from this point is the tensile. So now, right now, Matt, look at the number. We are at 100,000
Yeah, now
PSI.
keep in mind, this is not going to read as well now.
Exactly, because I
This is
removed
all that matters.
Exactly, Matt. We are at 800 MPa, double the strength of the bar.
Or now I'm starting to hear some cracking over here.
That's just the rib on the bar elongating. That's not the material failure. That's just the stretching. And I go back to PSI. Matt, we are at 140 KSI right now. That's 140,000 PSI.
Wow.
We only guaranteed MST bar to 145. That means I can literally turn off this test and all this gonna come back to the beginning. I'm gonna go back one more time to MPa.
But
Matt,
we're here to
that's
break stuff.
1,150 MPa. We are double
And climbing.
more than double. Matt, 72. PSI versus steel that only failed at 60 kPa. Matt, the bar completely went to failure, and now you can open the door and see how does those bars fail. Matt, you can see each of those fibers I show you exploded into pieces.
Yes. Now, to make sure that everybody has my understanding of why MST BAR is set apart from all of your competition.
Exactly.
No matter the length of the bar, the starting point to the ending point. And what I mean by that is 2 foot, 1 foot, 60 feet. It doesn't matter the length. Each individual fiber
Are continuous.
100% the same strand at the beginning as it is at the end.
Matt,
There
this
is no separation
the
till you
rib.
break it.
This is the rib on the bar, and you can see the rib on the bar are straight, complete single piece of roving, and that's where it makes those deformation on the bar to adhere to concrete.
I'm intrigued.
Thank you. Thank you.
I've seen, as stated earlier, fiberglass processes, but I never would have imagined that each individual fiber that is within that roll of multiple fibers within the rope stayed continual through the entire length of the bar. I mean, that just amazes me.
What you can see, Matt, is one of the reasons we have to put these metal tubes at the end is because the tensile force on this bar is so high that if we don't reinforce the ends of the bar, the machine will crush these bars from
Because of the
compression,
pinch
because of the
strength
pinching
of the clamp. And what he's talking about is that's just a great big clamp. And what they don't want to do is see a failure mode from the test because it crushed the outer fibers, which is part of the strength because all of the fibers are working together.
That's very true.
All right, Borna, now we're in the QC lab.
Yes, sir.
Tell us all about it.
Thanks, Matt. Matt, this is the area when all of our raw materials and some of the finished goods get tested and verified that they're according to ASTM, ACI, and CSA standards. We do the testing all the way from the polymer itself. We test the resin. You remember I told you 85% of this material is glass, the other 15% is polymer. We make sure these polymers that we receive are what manufacturers are claiming what they are. Reactivity, viscosity. We check all of this with these machines here.
So you test every incoming lot?
Every incoming lots of raw materials, Matt. We also test every incoming lots of the glass as I show you. But not only that, but every time we produce a rebar, we grab pieces of rebar from that production lot and we do series of testing mats on them. One of the tests we do, we call them fiber content test. This test is really cool, Matt, because we put a piece of rebar inside an oven and we put the temperature of on that oven at about 1200 degrees Fahrenheit for 6 hours. And what's left, Matt, is a piece of fiberglass rebar. That's what you see in my hand. We weighed this and then we said, what is the weight of this material compared to overall? And that's how we say about 80 to 85% of this material is made by glass.
So the temperature that you set it at, is that to break down the polymer?
The polymer only.
And remove moisture?
Remove the moisture. So
you're not weighing water?
Exactly.
Okay.
Exactly. Matt, the other machine we have is a DSC machine. This machine takes the piece of rebar. So what we do, Matt, we grab a piece of rebar, we punch a little hole in there, and you can see how tiny this is, and we place this little thing inside this capsule, and we seal this capsule and we place it in this machine.
Okay.
This machine is going to run from room temperature to about 600 degrees Fahrenheit and draw you a chart, as you can see. And this chart will tell you where the TG and how well that polymer is being crystallized, how well is this material basically is being cooked, the recipe. So it basically proves to you that your recipe has been perfect. Some of the other crazy tests we do, Matt, is we put a piece of rebar in water and we weigh these bars every day to see how much moisture they're absorbing. And then look at the scale, Matt. Matt, the scale that we test this is 0.00000 grams. I don't know, this material, this scale, if you look at that, Matt, it can measure air. That's how accurate this scale is. And that's
just because you disposition the air.
Exactly. So we measure how much moisture are we absorbing in these materials. These are very critical parameters to make sure that bar is made perfect in quality.
And again, that's every lot.
Every lot of materials.
So do you do a beginning of the run, middle of the run, end of the run testing?
We try to do random, Matt.
Right.
Our inspectors goes to the site, look at that batch of materials, take random samples, and he tried to take the random samples from the bars that he has doubt on it.
Yeah.
So we actually take those bars, and if those lots reject, we reject the whole lot. Knock the wood, we never had to reject the bar, Matt, because we do everything.
You just jinxed yourself. Then it's been recorded.
Yeah, all right. No, it's, as long as it's recorded.
Right.
But I can tell you, Matt, we do a very parametric quality control during the process, and we ensure that none of the bar goes bad without inspection.
Understood.
Thanks, Matt.
So you as a supplier, put myself in the frame here. You as a supplier not only set yourself apart with continuous fibers, I don't know if that was in view or not, but continuous fibers throughout the entire bar, and you test all of your incoming lots.
That's very true.
And you test throughout your process, and you test after the process.
That's very true, Matt. That's very true.
If that doesn't tell you the quality that MST BAR puts into their product, I don't know what will.
Thank you, Matt.
Well, I greatly appreciate the tour.
Thank you very much, Matt. Thank you
And
very much.
I believe there may be some positive outcome from this video.
Thank you, Matt.
For you guys. And we had a small conversation a minute ago about the quantity that one supplier produces of rebar. State that number again. You don't have to state their name, but how much metal rebar does one of the largest suppliers produce? Steel rebar.
4.5 million tons.
4.5 million tons. And you guys have less than 1% of the rebar market.
That's very true.
And you currently annually sell roughly how much?
About 65,000 tons of rebar.
1% would be 450,000, just to do some quick math for everybody there. So the fiberglass rebar has a very small portion of the market. I personally believe it's because people don't understand the technical aspects.
That's very true.
And the reason why it not only is beneficial for your labor force, lighter product. Yes, there's some PPE things that you have to do on the job site if you have to cut it. But again, MST BAR offers a solution for that, to where you're just grabbing bar and throwing it in the wall, grabbing bar, throwing it in flat work, grabbing a bar, throwing it in footings, in earth footings, form drain footings. So you don't have to cut it if you work with MST BAR. You can order a specific package. It'll show up on the job site, and it's going to be footer rebar, wall rebar, both horizontal and vertical, bent corners. And just to make sure everyone understands, and we'll talk about this in the application of the ICF edition, but there is a good, better, best for your corners.
That's very true. Good
being 2 straight bars overlapping each other and tied to make a 90. Better is a 90-degree bend that overlaps both straight pieces, 20 inches overlap on both sides.
2 feet,
Call it 2 feet. But best is a straight leg, a 45-degree chamfer in the center of the bar, and then another straight leg. And again, you guys will see all of that in application. We will trial the overlap and tie it together with a zip tie, but we're not going to leave it that way. We're going to, at minimum, go with 90-degree corners in the addition. But we are going to utilize 45s to show you guys the difference. So again, thank you for the tour.
Thank you very much.
It was greatly appreciated. And you are very technically inclined in your processes, and it's appreciated.
Thank you very much, man.
Well, hopefully you guys enjoyed the video. I tried to provide as much technical detail and as much insider information as I could, but there's always proprietary things whenever you have like in sales, I like to call it a better mousetrap than your competition. So you got to be careful with what you do share. So we shared as much as we could. Hopefully you guys enjoyed it. And as always, like, comment, subscribe.